If you want to know how to start out with a simple URL, access unstructured HTML, and transform that into a nice, neat, one-piece data table, stick around. X and I got some cool tricks for you. Hey YouTube, welcome back to the channel. It's your boy Taicho, and that's my Dark Lord X. Let's get right into it. So in the last couple videos, we've worked really hard to web scrape the first Saga data and then the One Piece arc data. And so continuing on our wonderful data engineering journey, we're going to web scrape the One Piece chapter data. So I've broken it up into a bunch of different steps. I'm going to call them captain's orders, since I'm Taicho, which means captain in Japanese. But I've broken them up into 4 steps, with some of the steps having a couple sub-stages to break up the code a little bit easier. So the first step is going to be the initial setup. Here we're going to import the packages. We're going to define a function to help us clean the text that we receive from our initial web scrape, and then we're also going to set up our foundational URL, which will be the starting point for our web scraping program. Step 2 is going to be data sourcing. I've broken this up into a few different steps, but we're going to initiate our data sourcing for loop by denoting a couple variables. From there, we will loop through all the different chapter hyperlinks, grab a bunch of different data fields, and append those to a list, which we will then, in step 3, format into a more readable, cleaner data table, clean up some of the data in that table, and then in step 4 we'll export that data table to SQL Server like we've done in the prior videos. So that's going to be captain's orders. X, my Dark Lord, will be helping us using his dog-a-jibbitis for Python, as well as his dog-a-jibbitis for SQL. So now that we know the captain's orders, let's get started. So the first step, as I said, it's going to be in our initial setup. We're going to start by first getting our packages. So X, if you give us a script for all the necessary packages that we'll need to web scrape the One Piece wiki fandom. So here are all the different packages. I'm not going to go too far in depth on them. Basically, a bunch of different URL packages, beautiful soup, pandas for the data frame, regular expressions for cleaning up, connections to SQL Server, and a time package to know how long we want, how long the whole program takes. From there, X, if you could give us a variable to kick off the start time, as well as a function to clean the text from all the different web link HTML data that we go and grab. Cool. So here's the start time variable. Basically just time that time to kick off the starting. And here's the function to clean. So we call that clean input. I've gone through this in my prior videos, but basically it takes an input, runs it through a couple different steps, primarily using regular expressions to parse out characters and symbols that aren't part of the everyday, alphanumeric library. So from there, what we need to actually get started is a base URL. So X, if you could give us a base URL as well as a couple different lists that'll help us expand on that base URL. So here we are. We have our first list, which is basically just going to be a list of numbers from 1 to 1087, excluding 1087 because that's how Python works. So basically it's going to be 1 to 1086, 1086 being the most current One Piece chapter. That's just going to be a list of all those numbers. And then we have a blank list called chapter list, and then we have a URL. So what we want to do, because we don't want to manually go to every single chapter and scrape data, that'd be crazy. We want to create a for loop that does that. But to do the for loop, we actually have to have all of the hyperlinks available. That's why we have this URL base here. So we have our base URL, and what we're going to do is take every number in this chapters list and append that to this URL base. And then after we append that number, or concatenate those two characters, we're going to append that full string to the chapter list. To do so, X is going to give us the for loop for that. Bam. So not only has he given us the for loop script, he also was helpful enough to help us put it in a data frame. So really simple for loop that has literally one step. For every number, for I in chapters, so for every number in this chapter list, we want you to take this base URL and concatenate that number to the URL, and then take that full string and add it to the chapter list. That's what 2 lines of Python would do. Pretty cool. And then from there we throw that into a data frame. I'm going to give it a column name called link because we only have one column there. So we can actually run that and see what this looks like now. So here are our different chapters and the links to them. I can open this up just by clicking on it, so we know it's a real hyperlink. It brings us to the One Piece Wiki fandom. In the One Piece Wiki fandom, what we're going to be searching for is this chapter info over here. We want the volume chapter, the title, the number of pages, the release date, and the Shonen Jump issue. I chose those fields because those were kind of the easiest out of all these different ones to clean up, grab, and whatnot. How we do that is essentially, if I was a human, well I am, but this is how I would do it. I'd right click, I'd hit inspect, and it'd bring up all this HTML info. But in this HTML info, you can kind of see that there's a relative structure to it that has different classes in there, different headers, and in those headers there's different text values. So that's what we're going to do in step 2, the data sourcing, for every single link in our data frame list. Pretty cool. Cool. So X, if you could kick off step 2 for us by providing the 2 lists that we need for the variables. Sweet. So 2 quick lists here. These are the data fields that I just identified that we want to capture. The volume chapter, the name, the date, and the jump issue. And then a blank list called chapter details list. Basically, at the end of all of our data sourcing, we're going to put a list of lists in here. Sweet. Cool. So now we're going to move on to step 2A. X, if you could give us the script for to kick off our for loop, basically just define some of the variables that'll be created within that for loop. So here we go. We're kicking off the for loop. So for every link in that chapter data frame, so for every one of these links, we're going to do a bunch of different steps. Very similar to what we've done in the past, so I'm not going to go too far, but basically we're creating a list within this for loop. We're appending this link to that list. That'll be the first, essentially, the first column in the data frame that we output in the very end. We're opening that link. We're using Beautiful Soup to parse the link that we did. So basically, just as I right-clicked, open it, that is what Python will be doing, and then it'll be inspecting all the HTML data in the end. But that's not good enough because that returns nothing but a bunch of gibberish. So what we want to do in step 2 is kind of refine the information that we grab. So X, if you could give us the nested for loops that will iterate through each data field that we mentioned up here and grab that particular information for us. Nice. So here we go in step 2b. So within this for loop, after we've opened up every link, we're kicking off a couple more for loops. So for every link that we open, we then want to search for every one of these elements in this data capture link list. And what that does will help us refine the information. It's going to go through every single link, look for the particular elements that I've identified, basically searching for certain HTML elements, tags, and attributes, grabbing the attributes from those tags, taking the text from those attributes, running it through the function that we created up there, the clean input function, cleaning it down, refining it, and adding it to the link list. So each one of these elements that we go through and we web scrape is going to become another column added on into our data frame. So I was able to do that pretty neatly for all these, but in order to get the page numbers, it was a little bit trickier. I had to kind of run that separately. So X, if you could give us the for loop for those page numbers, that'd be awesome. But I think that's a pretty cool data field to see how long each chapter is, over time has only given us shorter chapters. We'll see. So this is essentially the same script, but we're looking specifically for page. Since page is a numeric variable, I could tell, I could be a little bit more specific with the fields that I extract. Basically, I'm only looking for digits, and if it's a digits that's found after refining all that HTML text by looking for a specific page, it will append that to the link list. And then we'll have a chapter detail list. So I'm not going to do that right now because actually I can. If I refine this down to 3, I should be able to do that. And let's see what we have in our link list down at the bottom. So let's print that. I'll print the chapter detail list. So this is what the list looks like, and you can see it's not pretty. It's in this kind of long form, comma separated object, which is good for manipulation, but X, let's turn that into a data frame. My man, thank you. So now I'll rerun that one more time, but instead of the list, we'll have it in a tabular format with our columns. You can see we have the link, the volume, the chapter, so on, the date, the jump, issue, and the pages. Exactly how we defined our variables. But if you notice, there is some added information. Basically, I just want some of these to have just the numeric info, just the date. So all these consistent formats. X, give us a script to clean all that junk out, my boy. Now, admittedly, data cleaning is not my strongest suit in Python. I have to do this kind of manually, and I'm not going to go through all this, but basically what I'm doing is, for the different columns, sometimes I'm splitting at certain points and keeping everything after, or I'm just replacing, or I'm slicing, but basically that'll give us a cleaner data frame. So I'll run this one more time to see what that looks like. Nice. So you can see it's, for the most part, cleaner for the ones that we needed to be cleaner. I kept jump the same because I just kind of split that out into the year and then the actual issue. Number of pages, 53 to 23. You can see the date. So this is some pretty good info compared to the saga and the arc data that we have. A little bit more, or much more granular. And so now we're gonna export that into SQL. I've done this a couple times and explained in depth, but I don't do so again. So give us the export script. Let's get it done. Nice. So here we go. Same structure in the previous videos. We define our connection strings. We define a cursor variable that allows us to execute SQL scripts with our dog activities. We, drop the table if we have it, and then from there, we create a table with these fields, and this is the data type. I've only been using variable characters for now. And then we run a for loop. So basically, for every row in the chapter data frame that we have here, we want to try and insert each of these columns for each row into these rows, into these columns in the table. I'm sorry. And then after that, we commit the changes that we made and we close it. So I'm going to go up here, changes to 1087 so that we have the full chapter list, and I would run that. Now, I'm not going to run that now, primarily because this will take a good amount of time. I've already run it, and let's see what it is. So I'll refresh, see if we have a new table here. Chapter details, baby. And let's just select the top 1,000 rows. We get rid of top 1,000. So we execute. And here is our clean data for the most part. Cool. So, this is interesting. This is too. So you can see all the chapters. We have the length, the volume, the chapter, the title, the date the chapter was released, the jump issue, number of pages, the year, and so on. So, first One Piece chapter came out July 19th, 1997. We are in 2023, and Oda has only turned up the temperature. If I scroll all the way down, we have the Five Elders chapter. My God, if you guys, I'm not going to spoil it now, but if you are caught up, let me know what you think of where One Piece is right now. I think it's in a phenomenal place. We've been on this void month, kind of a hiatus type of period, but July 18th, I believe, will be the official release of 1087. My thoughts are we'll probably be jumping back to Egghead to get a resolution to all this bullshit that York is doing. It's kind of wild. But yeah, I don't want to go too far into spoilers if you're not caught up, but it's pretty cool. We're in the Egghead arc right now, the final saga. I've done a little bit of analysis. You can check that here on that data. But yeah, so here's all of our information. And it's a lot more rows than we've had. So, 1086 for every chapter. The saga data frame, saga table we created only had, I think, 11 or 12 sagas. Then we went to the arcs, which was only about 32. And now we're at 1,086 rows. I think that's been a great way to enrich our database. We now have 3, and we're not going to stop there. So if you're liking the video, please give me a subscribe or a thumbs up, comment. Let me know what you think about this project that we're doing. If there's any questions in the Python, please let me know in the comments. Any other data sources you think would be interesting, let me know and we can work to enrich that. But stay tuned. In our next video, we're going to use every link from here to increase our volume by web scraping all the One Piece characters that have ever shown up. That's going to blow up the database and really put us in a great position to expand on all the content that we've created. But until then, Taicho out. Deuces.